Today we are going to begin our intro to exponents. As you can see below, we have number 2 multiplied against itself multiple times. What does this mean? The number 2 is a base, and a base is the common factor or the number that is being repeated. As you can see here, we are going to have our base be indicated or written, and then we're going to add an exponent. Exponents are used to show repeated multiplication, and the number shows how many times the base is used as a factor. This means that we're going to take the number that is most common and repeated. We're going to count how many there are. 1, 2, 3, 4, 5, 6. So we're multiplying 2 by 2 by 2 by 2 by 2 by 2 to get an exponent of 6. This is consolidating or combining all of those 2's with a base and exponent to indicate that this 2 is multiplied 6 times to get the answer. Here again, we have our base and exponent, but this time we have what's called a power. This is a written power. It is read as 2 to the 6th power. Now you can see bases written by themselves. They're just general numbers. But this exponent can never just be hanging out in space by itself. It needs to be connected to a base to hold it up and be what is going to be multiplied. So the power is the product of repeated factors. Product, again, remember, means the answer to multiplication. So the multiplication answer of repeated factors or numbers will be the answer. It has 2 parts. The power has the base and the exponent. This expression is again read as 2 being the base, to the 6th power, 6 being that exponent. Now you don't have to write all of this down, but it would be good to maybe jot a couple of them. So how would we say these different items? Our first one is 12 to the 1st power. Our base is 12 and our exponent is 1. When we have just a single 12, our answer or value is going to be a single 12. For the second one, we have 6 to the 2nd power, or 6 squared. When we were working on this before, we had our square, and it was a perfect square. All the sides were the same. So this was a value of x, and this was a value of x. So our square was x times x, which in exponent form will be x squared. The next one is going to be 2/10 to the 3rd power. We're going to multiply 2/10 by itself 3 times. In this sense, it is going to be called 2/10 cubed. Now our cubed, you think of a box. For x squared or the 6 squared, we saw that we just had a square. Now this is going to be turned into a cubed to a box. In that new value, we are going to also add the height. So we have x times x times x, which gives us x to the 3rd power. For -7 to the 4th power, it can be read differently. In this example, only the 7 is being multiplied to the 4th power. and then taking the negative of. So you can see and count that there are 1, 2, 3, 4 sevens that are multiplied together and then is multiplied by a negative to give us negative 2,401. As a teacher, since I know that this can be read two ways, I'm going to help you out. I am going to add an additional set of parentheses around that exponent and that 7 to help you see that it is going to be first a 7 to the 4th power and then a negative value of that. So this would be read as 7 to the 4th and then the opposite of it. So opposite of a positive is then a negative. For our next one, we have negative 8. Now the negative 8 is inside the parentheses. This is indicating that we're going to take negative 8 and multiply it to itself 5 times. So negative 8 to the 5th power. So that's negative 8 times negative 8 times negative 8 times negative 8 times negative 8 equals the sum or the product of negative 32,768. So let's do a couple of examples. So our first example, what is our base? Remember, the base is the repeated number that is seen. So in this case, our base is going to be 1/2. So let's write down 1/2. Now, how many of those do we have? Let's count them out. 1, 2, 3, and 4. So this is going to be 1/2 to the 4th. Now, we know that the base was 1/2, and we know that we have 4 of them. But if I were to walk away and come back and look at this again, I might see 1 to the 4th divided by 2, which would give us a completely different answer. If we had 1 over 2 with the 1 going to the 4th power, 1 times 1 times 1 times 1 will give us 1 all over 2. Now, if I go back and I add in some parentheses around this value of 1/2, I know that that base value is 1/2, and I am multiplying 1/2 4 times. So that will end up being 1/2 times 1/2 times 1/2 times 1/2, which will then equal 1 over, let's remember our fraction rule, 2 times 2 is 4, times 2 is 8, times 2 is 16, because we're multiplying straight across. So this answer, with our answer in the parentheses, we are going to have that be 1/16. So we had our answer, our base in the parentheses to indicate that this is the whole entire thing, and we're taking that to the 4th power and getting 1/16. Whereas if we only had the 1 to the 4th power, we would end up with 1/2. So parentheses matter. I would rather see more parentheses to clarify than to leave it up for me to guess. Our next one, how many sets of bases do we have in this one? I see 2 sets of repeating numbers. I have 4, and I see that we have a 5. We have 1, 2, 3 4s. So I'm going to give myself my exponent 3. And 1, 2 sets of 5. Now, we have what as our notation? What is our function between these? We have that we are multiplying all of these together to get 4 to the 3rd times, we're not going to use x's anymore because we use variables now, times 2 or 5 to the 2nd. And this will give us